Welcome to Ask and Learn.
We'll figure out our radius of convergence without taking any shortcuts. We'll just use the ratio test here. So limit as n goes to infinity of an plus 1 over an, where an is this whole chunk here, including the x values. Okay, so this might get a little messy. So this is limit as n goes to infinity, absolute value. X to the n plus 1 divided by x to the n is just x. Okay, and then we still have this n plus 1 factorial, and we still have this whole chunk happening down here, 1 times 3 times dot 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 times 2n minus 1 times 2n plus 1 minus 1. For the an plus 1 guy, we have to go all the way until 2 times n plus 1 minus 1. And dividing by an is the same thing as multiplying by the reciprocal of an. So now we're going to be multiplying by 1 times 3 times dot 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 all the way up to times 2n minus 1. And we're going to be dividing by n factorial. Okay, so this chunk here is going to cancel out with this whole chunk here. The 2 times n plus 1 minus 1 is going to survive. And n factorial is 1 times 2 times 3 times dot 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 times n. So we're going to get everything with the n factorial to cancel out with the n plus 1 factorial. But the n plus 1 in the n plus 1 factorial will survive. So this is going to be simplified to limit as n goes to infinity, x times n plus 1. Nothing's going to cancel out with the n plus 1 here. And then nothing will cancel out with this 2 times n plus 1 minus 1. So that's still going to be there. Okay, as n goes to infinity, n plus 1 divided by 2 times n plus 1 minus 1, that's going to be 1/2, because this is a linear term with leading coefficient 1. This is a linear term with leading coefficient 2. So as n goes to infinity, the limit is 1 divided by 2, which is 1/2. So this is absolute value of x over 2. And when we're trying to figure out where we get convergence with the ratio test, remember we want for this to be strictly less than 1. Okay, so that means that absolute value of x is less than 2. So the radius of convergence is going to be 2, right? Because x is going to be trapped between -2 and +2. So the length of that interval is 4. Radius of convergence is half of the length of the interval of convergence. Okay, so now we need to figure out whether or not we include -2 and whether or not we include 2. Okay, so what happens if we plug in x equals 2 here? If x is equal to 2, then we have n factorial times 2 to the n divided by 1 times 3 times dot 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 times 2n minus 1. Okay, so remember what x or what n factorial is. N factorial is 1 times 2 times 3 times dot 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 times n. 2 to the n is 2 times dot 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 times 2, where we have n different copies of 2 here. So if we multiply n factorial by 2 to the n, we can do 1 times 2, 2 times 2, 3 times 2. Each one of the factors in this product can be multiplied by one of these 2's here. And then we can write this as 1 times 2, which is 2, 2 times 2, which is 4, 3 times 2, which is 6, dot, 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 all the way up to 2n. And we're dividing by 1 times 3 times dot, dot, dot. I guess I should put a 5 here so we have the dot, dot, dots in the same place, times 2n minus 1. All right, but now if we just put parentheses in the right place, then we can see that this is not going to converge because the terms are not even going to go to 0. So we just put parentheses around each of the guys here, put parentheses around 2 over 1, put parentheses around 4 over 3. Dot, 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 keep going until we have parentheses around 2n over 2n minus 1. And notice that each one of these terms is bigger than 1. So this whole thing has to certainly be bigger than 1. So in particular, it can't possibly go to 0. So these terms do not go to 0. If the terms don't go to 0, then we can't possibly get convergence. So we get divergence. And we get the same type of thing happening if we plug in x equals minus 2. If we plug in x equals minus 2, we get the same type of thing, except now we would have a minus 1 to the n happening here. But again, it's not going to change the fact that our terms are not going to 0. Okay, so we get divergence if we plug in 2 or minus 2 into our sum here. So both of those values we have to throw out of our interval of convergence. So we leave this as an open interval here. So not including minus 2 and not including positive 2.